Kia ora. Today we're going to have a little play with some liquid nitrogen, which we've managed to get from NIWA, and we're very grateful to Rowena and Christian at NIWA for letting us use their liquid nitrogen. First off, if you're using liquid nitrogen, we do have to be aware of safety, and for that reason we've got the door to the lab open and windows open so that any nitrogen evaporating will be free to move out of the room without displacing all of the useful oxygen. So we've got the liquid nitrogen in a thermos, and we're going to do a couple of demonstrations with that, and then we'll wrap up. So we've got the liquid nitrogen here, and we're going to use some tongs. And we'll start off with a nice pressure and temperature demonstration with balloons. And so as we lower the balloons into the liquid nitrogen, we get a lovely bit of bubbling. So I really like this demo for, the awe and wonder of being able to shove multiple balloons into a relatively small chamber, and then being able to draw them out and watching that beautiful expansion. Okay, and then the other classic that most of us will have seen or maybe even done before is the flour. And so we will lower the flour into liquid nitrogen. And depending on how much liquid nitrogen you've got, it's really useful to have a nice long stem so that you can hold it without having to try to manipulate it with tongs. Now you can tell when the object that you're putting in there has reached the same temperature as the liquid nitrogen, because the bubbling, the boiling of the liquid nitrogen will cease. And so now there's no bubbling going on, and so I've got a pretty good idea that the flour is at temperature. And so if we draw that back out, and then I'll try and hit the desk with that and we'll see what happens. And so you can also demonstrate that Leidenfrost effect. If we spill liquid nitrogen onto our hand, then it's the Leidenfrost effect which prevents the liquid nitrogen from freezing the cells. We've also got the outside of our skin as dead cells, so hopefully as long as I don't immerse my hand in liquid nitrogen, then I should be fairly comfortable. Okay, and I can feel the cold. And if you've got a little bit gets in between your fingers, then that can be quite chilling, but the effect is similar diameter to the pipe, and so when we drop that down, it takes a little bit longer to get through. Much more noticeable difference, didn't it? All right, so what we're trying to do here is collect liquid nitrogen in a vessel, in this case a Coke can, and the liquid nitrogen on the inside will cause condensation on the outside, and that condensation should allow the oxygen that's in the air to liquefy. The boiling point of liquid nitrogen is negative 196 Celsius, and the boiling point of liquid of oxygen is about negative 183 degrees. And so the hope is that we'll be able to collect more liquid oxygen than liquid nitrogen.
Oh, that is liquid
Oh,
oxygen.
look at that. That is beautiful. Okay, so what we've got going on here is the liquid oxygen in the bottom of the beaker, and oxygen is paramagnetic, and so we can draw that liquid oxygen. Hopefully you can see that being drawn up the sides there. Oh, yeah.
Not too close to the magnet, right?
Oh, look at that. I don't know, I'm hoping that you're getting that. Yeah, that's awesome. Whee! Bring it over here. Oh, that's amazing.
I hope being on camera.
Whee! So what we're going to try here is to drop a match into the liquid oxygen, and I think we saw as we popped that in there we got a nice flare up. There we go. Beautiful. So one of the questions Arno asked was, why do we see this very distinct line between the frost effect and the unfrosted can? So we had a good bit of time discussing that, and we welcome your thoughts.